What's up, guys? In this problem we are asked to solve a problem with elasticity of demand and using ODE, so differential equations, and we are given an additional condition. Right, so let's solve this. So the first step is knowing that the elasticity is given by the expression minus P divided by Q, and then dq divided by dp. You need to know this one for elasticity. So knowing this is pretty much the only thing. So knowing this is the first step, and now you're going to equal this to the expression that they have just given you. So it's 3p p squared plus 3p plus 2. And now you notice that this is a separable ODE. You can aggregate the p's to one end and the q's to the other side. So this is what we're doing right now. So we get minus 1 divided by q, and then the integral of this dq, and then that's equal to the same thing. So you get this p to this other end, and you get the dp to that other part. That's all we're doing here. So this is 3p divided by the p that you got from this end, so it came down here, so p, and then times what you have in the denominator, so 3p plus 2, and this is dp. So this, all we did here is just understanding what type of differential equation that we had here, and just separated the elements between q's and p's. That's all we did here. So the next step is just to solving this. So this one is easy. This is minus ln of q, and every time that you have a situation like this, the first step is finding elements that you can eliminate. In our specific case, we have this one and this one, and now because we have this in this form, we know that we're going to use fractions. So the way for us to solve it is just, for now, let's just ignore the first solution that we found and just use some auxiliary calculations to solve the other one. So let's do that. So this second one, so we have 3, we can get it to the other side, and then we have 1 p squared plus 3p plus 2 dp. So let's focus our attention just on this one. So a is equal to 1, b is equal to 3, and c is equal to 2. So we know in order to solve p, that is equal to minus b, same old b squared minus 4ac, and then divided by 2a. So in order to find the solution, we just need to plug in the numbers, and you're gonna get that it's p1 it's equal to minus 2, and p2 is equal to minus 1. So these are the two values that we have to work with. And one thing to notice about this, and sometimes I get confused with this one, and the way for us to solve this is knowing that you are saying that p is equal to minus 2, and you are also saying that p is equal to minus 1. So when you plug these back into the expression, what you are saying is that because this is 1 and you are equaling the expression to 0, so this is why you change signs. So you have the same thing for the other one. So remember, you are saying that the solution that you found here, it's minus 2, and minus 2 plus the number that you have existing there gives you 0. So you're doing the same thing for this one. Because sometimes you see some exercises that they do it too fast and don't explain it properly. So all we are doing here is finding zeros, and you are finding the value that p is equal to 0. So you found this value and you found this value. So it's minus 2 gives you 0, and minus 1 gives you 0. So now that we found this expression, all we're doing is the method in order to find the values for this one. So you do 1 is equal to a divided by the first one, p plus 2, plus b divided by p plus 1. So to find this, you multiply this by p plus 2, and then p plus 1. So because you have p plus 2 here, you're going to get p plus 1 on the top, and because you have p plus 1 here, you're going to get p plus 2 on the top. So let's do that. So you have 1, it's equal to a times p plus 1, so p plus 1, and then you have the other one, so it's b times p plus 2. So because you found the zeros, you have that this is minus 1, so you can test it. So p minus 1, so what does this give you? This gives us that it's 1, it's equal to 0a, so this one goes away. And then we have b, and then minus 1 plus 2 is equal to 1. So you have that b is equal to 1. So you have, because this is 1, so you have that b is equal to 1. And for the other one, let's do it in a different color. So if it's p, it's equal to minus 2. So 1 is equal to minus 2 plus 1, that's minus 1a. And then plus 0b, because it's minus 2 with plus 2, so this one goes away. So you have this one. So a is equal to minus 1. So you have two solutions here. So the integral is now minus, you can get a minus 3 out. So this is 1. Remember, this is a divided by p plus 2. And then you have the second one. So plus 3, nothing changed. It's just the b that is positive. So this one is 1. So you have 1 divided by p plus 1 dp. Forgot this one here. So this is what you have to work with. So this is minus 3 ln of p plus 2. Always have the module there. Plus 3. And then ln of p plus 1. And now we have this expression. We can even further simplify this a bit. But before, let's get back to our initial expression. Remember that the first one that we found was that ln q. This was our first one. Now it's equal to what we have here at the top. So ln, just write this down, p plus 2, and then plus 3 ln of p plus 1. This is what we have to work with, and plus c, obviously. So now that we have this, we can even further simplify this by using properties from the logarithms. This one, because it's minus ln of q, this is the same thing as saying that it is ln of 1 divided by q. This is the same thing. In this one, we have a subtraction, and we have the same element, which is 3. So you can arrange this in a different way and have it like this. So p plus 1, it's the positive 1 divided by the negative 1. So now that we have logs on both ends, we can even further simplify this a bit. We can even get this to the top. So we have ln of 1 divided by q is equal to p plus 1, p plus 2. This one, the 3, goes to the top. And then you have plus ln of c, which will end up being a constant. But we'll get to this one in a bit. So now we have, because we can use the e to both sides, so this is ln as well. So e to the both sides, we get 1 divided by q is equal to, because this is a sum, using the properties of the logarithms, it's the same thing as saying c, p plus 1, p plus 2, all of this to the third power. And now, because we have this inverse, we need to inverse it in order to get the function. So this is q is equal to 1 divided by c. This one goes to the top, and this one goes to the bottom. We haven't changed anything really, just inverted the expressions. So we have the expression now. We are told in the beginning that q of 1 is equal to 27. So all we're doing here right now is just substituting back the element. So 27 is equal to 1 divided by c, and now we have 1 plus 2, and then 1 plus 1. So this all cubed, and this gives us, so 27 is equal 1 divided by c, and then 3, 2 to the third power. We can even further simplify this because these are small numbers. So this is 27 equals to 1 divided by c, 3 to the third power, that's 27, and 2 to the third power, that is 8. So we can get this one, this comes out, and we get this one. So we can get c to that other side and 27 to this other side. So we get c is equal to 27, 27, and then 8. This 2 goes away. So we have c is equal to 1 divided by 8. Now we can plug this back in the expression, and we just need to rearrange it in order to accommodate for 1 divided by 8. So qd p is equal to 8, and then we just rearrange the terms again. So it's p plus 2, and then p plus 1 to the third power. This is our final expression.